So when you bring air resistance into it, it's a little bit more complicated, because let's go back to this ball about to start falling. Now, as it's about to start falling, the only force that is acting on it is its weight, which is mg. And so the acceleration is going to be g, which we said a moment ago. Now, at this point, this is when the velocity is 0. Okay, I'm using the general symbol for velocity there, because we're talking about the velocity at this very moment. We're not talking about starting or finishing velocity. We're just talking velocity. Okay, so this is when it's just about to start moving. It hasn't started moving yet. It's about to. The acceleration is g, and the resultant force is mg. Now it's started moving a little bit. So let's say, so now we're going to say that v is small, right? It's just v is. Let's just do that again. v is small. Okay. Now there's a little bit of air resistance, right? Because air resistance is entirely down to how quickly something is moving. When you're going down a slope on your bike or something, you're going to feel some air resistance. The faster you move, the more the air resistance, more air resistance you'll feel, right? Okay. Now the weight, that's a force slowing it down. The weight that is speeding it up is going to be the same size. Okay, so that's mg, and we're going to have r, and r, which is the air resistance, is also small. Okay, so the force is now, the resultant force is actually now mg minus r, and the acceleration, well, that's going to be mg minus r divided by m, because remember, acceleration is equal to force divided by mass, right? So now that means the acceleration is reducing, but it's still accelerating, it's still getting faster, but it doesn't keep getting faster forever. Eventually, because as it gets faster, it's still increasing in speed at the moment. As it gets faster, the air resistance gets higher, and eventually there's going to become this maximum point because once the air resistance is the same as the weight, so at this point the air resistance is equal to the weight, then at this point, well, so let's just write, I'm going to write weight as mg from now on. Okay, because w is just equal. Oops. So that's r, and that's weight. At this point, the force was still mg minus r, right? But now r is a lot larger. R is as big as the weight. So mg minus r is going to be 0, right? R is the air resistance. Yeah. So the force is now equal to 0, because while it's been falling, whilst it's been speeding up, the air resistance has been increasing. And now it's big enough. Now it's as big as the weight. The force of the air resistance is as high as the force of the weight. And so, okay, go on. So, first of all, in this situation, no, we don't know what the air resistance is or anything like that. But it does depend on something other than the speed. So it depends on the speed at which the velocity at which you're moving through the air. If you're moving faster, then you're going to have a higher air resistance. But it also depends on the surface area. When you think about it, that makes sense, doesn't it? Right. So if you're more streamlined, you don't experience as much air resistance, and if you're less streamlined, of course, you do. So that's why we have parachutes to slow us down, and that's why we have things like darts that are designed to go fast, so they don't have that much air resistance. So these are the 3 different stages. I'm just going to separate them out a bit. Oops. Yeah. So we start off with the velocity is equal to 0, and at that point, the only force is the weight. That means the acceleration is at the maximum. It's equal to the gravity. Later on, we have the force is slightly smaller because we've got a bit of air resistance that's counteracting it. So we have to subtract that. That's the R is the air resistance. And then, so the acceleration is going to be smaller too. Eventually, you're going to have a point where the air resistance is now matching the weight. And at that point, the resultant force is going to be 0 because you've got weight minus air resistance. Okay? The faster you go, the higher the air resistance. Yeah. So and that's why eventually, as you're getting faster and faster, as you're getting faster and faster, the air resistance is increasing. So we have ended up at a maximum speed or maximum velocity called terminal velocity or terminal speed. And that would be and that would be dependent on the surface area of the thing that's moving. Okay.